Hello, welcome to stream number 48 in a series of streams where I program an NES game live on Twitch. Sorry for starting a little bit late here, but had some stuff going on, some projects being done here, and it was a little busy, so apologize for that. And just a little announcement, and I'll post this on the recording and in Twitter as well. There will only be one stream this week. I'm just going to stream today. Man, something like an eyelash or something bothering me here. I'll only be streaming today, and I won't have a second stream on Thursday of this week just because there's a lot going on. So we'll resume our normal schedule next week. So let's see what we can do today. So last time we had gotten the asset tool to allow us to build metatiles and add collision areas to them. And so what I did was I created this, and it's a little hard to see just because of the way that it's colored. If I turn off the grid here, you can see the parts that are highlighted. So I made this part collidable, and this part is not on the outer edge. And what I want to do is I want to essentially make this be something that's on the map, and then we will talk about how we're going to export the collision data, and yeah, and then I think from there we'll start implementing the collision in the actual NES game. So save that as bumper TSX, and let's go back to the map. And what I'm going to do is I'm going to clear out most of the map here, and I'm just going to put some of these bumper blocks here. Basically I just want to have them, they would realistically be something that, you know, you might have extended pieces over here, but I want to just start with sort of the basics of trying to see if we can collide with the one metatile, and then we'll add these blue ones just for I don't know, just so that we have something in between. Alright, so let's export that. Yeah. So if we go back to the map, we'll see that there's so that's at the bottom of the screen. So there are the bumpers and the blue tiles. So let's export that. Let's put that into the game. So let's see what that looks like now. Oh, right, the controller's not plugged in. Cool. So our background got loaded. That's exciting. Wasn't sure. There's always a little bit of nerves when you try something new like that. So cool. So the bumpers got loaded properly. All right, so now that we have that, the problem we need to tackle is we're exporting this collision data, but we're obviously not doing anything with it yet in the export tool, in the asset tool. So let's change that. I think what we would need to do is just have essentially another binary file that exports out the collision map for the metatile, which is the 2 bytes that make up the collision. And in doing that, we will have a 16-bit value that we can do a quick check of. We can, trying to think of how we would want to do that. Probably load the 2 bytes and store them. And as we're loading them, which we would need to do anyway, we check them to see if they're both 0. And if they're both 0, then we don't need to do the collision check anymore, because we know that there's no collision. And then if there is, if it's a non-zero value somewhere, then we have to check where the ship is in relation to the metatile, the specific metatile, and whether or not it collides. So what I want to do to start off with is highlight a byte where we are basically recording or showing whether or not we think we should check the more granular collision to start off with, and then we can get into the subtile collision. So, all right. What are we doing? So we've got the level here. We've got the map palette, the map lookup, the buffer. And these are the metatiles. So what we can do is we can say fprintf metatiles ink bin collision, call it empty collision dot bin. I actually want a label here, I guess. Am I doing this in the right place? Let's take a look at our files. I haven't looked back at these files in a while. So this is the palette table. These are the metatiles themselves, or the individual metatile palettes. We have that loaded in 2 places. This is just some code that I had copied. These are the char-rom files. These are the actual files, the char files that we generate. I don't know what that's for. This is other stuff we had open. So let's see. That's our code to draw the entities. That's our palette table, the palettes, the title screen, and the char-rom. Okay, so what we want to do, we have the metatiles as a bin file here. What I think we can do is move this. And where are we including that? Oh, I see. So I'm just doing, I can just do this. So we can just export that. All right, so we need to create another file here. So we open that, except that we actually want to use sopen s because we want to do it in binary mode, not text, which means that this should be an int. That's fine. So, and then this changes. This is write only, binary, create, deny no, write okay. So that's that. So that's going to create our collision file. I think I just called that MT collision, not metatile collision. MT collision. Okay. So we have that, and then what we want to do is as we write our metatiles out, so that's the empty, right? So then similarly, so we're writing out the metatile, the empty metatile, and then we're just writing out 2 bytes for that collision buffer that identifies this as non-colliding, which is what you'd expect for the first metatile. And then let's see, empty metatiles gets so empty tiles. So that's this. So that's writing the individual bytes of the metatile out. And then what we want to do is we want to write our metatile collision, and we want to write the 2 bytes that make up that collision. So that's the actual, really? That is different. Where is the that's the map metatile. Where's the actual metatile? Exported metatile. Let's see. Exported metatile. Is that the one? I guess that's the one I want. So let me do this over here. Okay, right, because it's looking at the metatile file itself and loading it here to do the final export. I forgot about that. Okay, so exported metatile, which is kind of a bad name because it makes it sound like it was already exported. It's the one that we're loading for export. So we're gonna write out the 2 bytes for collision. Current background tile. let's rename this to so what we should see is that we will go through and export the metatiles in the same order, with bumper being 1, 2, 3, 4. So we'll see all zeros except for the 4th metatile that we export. We should close that. Okay, so let's run that. Export the project, and then let's go look at that collision file. MT collision. So let's see here. 0, 1, 2, 3, 4. Yep. So go back. 1, 2, 3, 4, and then that's the asset filler. So in terms of the actual order of the metatiles, that's correct. And so now we should be, this should complain that that file's not there, so let's copy that over. Okay, so now let's do this. In the game loop, let's find where we're changing the player's position. It's loading the next tile. I think what I actually want to do, we will turn off the process of scrolling right now. Maybe. Because the thing is, what we need to do is we need to take the player's current position, compare it to their location on the map, and that might be the next thing we have to do, is because right now the player's position is based on their position on the screen, and it's not, there's really no sort of camera. What I mean by that is we've kind of been cheating this whole time, where we've said, here's your screen, and then we have these counters that are kind of running in the background, just looping over and over again and moving the screen, helping the illusion of the screen moving, right? As we load more tiles up in the name table here, the screen is moving up, so it makes it look like we're flying over something. And the player is kind of in this spot towards the center of the screen, but that's because the player isn't actually moving. The player's position is fixed. And the reason we can get away with that is because we're not using a real camera position to determine where the player is on the screen like you would in you know, a 2D or 3D game normally, which is fine for when you're getting started. But what we really want to do is we want to say, we've got this world now here that's this long single direction scrolling world. We have a camera that lives at a position here at the XY, where X is always 0 essentially, but in more arbitrary terms, you could have a world that's this whole area, right? And then the X could move back and forth if we wanted to do four-way scrolling, but for the sake of this being something that I'm doing for the first time on the NES, let's keep it simple. X is always essentially going to be 0, and Y is decrementing from some position here to the point where the camera becomes 0 here. You could do it the other way. You could say that the camera position is 0 down here and up, but I think that that is easier to work with. And so the player now has to be at a position here offset by the camera position. And so right now we're doing this player's position based on its absolute terms in the world, on the screen, rather than its position in the world, and that's what we're going to have to change. And then before we set up the sprite memory, we offset the player's X and Y by the camera position. It's just a simple subtraction, right? Where we say, okay, take the player's X and Y coordinate and subtract it from the camera X and Y coordinate, or in this case, really, it's just the Y coordinate. We don't have to do the X calculation. And then that's the player's sprite position on screen. So we can leave X position as a single byte, but what we want to do, I think, is change this Y position to be 2 bytes, because if you figure that the screen has to scroll across, how many tiles is this? I think it's 100. I closed tiled. So it's 100 tiles, 100 metatiles high. Each metatile is 16 pixels. No, 32 pixels high. So it's 3,200 pixels, which means that it doesn't fit into 8 bits, right? You need a 16-bit value to represent that. So let's see. Can you do nesdev? No. CC65 struct. I don't remember what units allows you to define as, if it's just byte or it does have word. So a word is just a 16-bit, which is what we want. So that's that. And then we need a camera. Which is really just the Y position. There may be more stuff, which is why I'm making this a struct, because you never know what we might need to do. We have this camera Y here, but that can go away. Or actually, it doesn't go away. We can say res size of camera, and just make this called camera. Size of camera is unknown. So because I'm reusing, invalid 45. Y. Oh, you can't say Y because that's a register. Camera Y is undefined. Where am I using that? 815. Oh, I'm actually using that. Let's use something different, because I want this to represent the actual absolute position of the camera in the world coordinates. So you have scroll Y and tile Y and M tile. I have all of these kind of jumbled up here. Let's move these together. Call this scroll counter. Make sure that still works. It shouldn't have broken anything, but I'd rather know now than when we come to it after making a bunch of changes, and then we have to figure out why and where and what. All right. The other thing, I don't remember where we are with our commits, but we should commit these changes now that we're gonna add a pretty substantial change. Let me just see what we've changed compared to the last commit here. Got rid of those repeats because it seemed to be messing up messin'. Right, we moved that stuff. Okay, so take a look at this. What am I saying? Metatile palettes load into the attributes properly now. Commit. Okay. Cool. So our camera. And let's see, so we are loading max rows here. This is how many rows, and like I said, that's 100. And then what we should do is we should also calculate what that looks like in terms of pixels to put into the camera position, right? So we want to multiply that by 32. So ASL, and then let me think about that. How would we do that? Can use the camera position as our storage. So if we got the value of 100 in decimal and we left shift it by 1, what we can do is we can store A in camera Y, and then we do a shift left, and then store that in camera Y again, and rotate left camera Y +1. How did we do this last time? We just did store, load, rotate left. Oh, right, because it's on the carry bit. Yeah, store, load, rotate left, store it back. Can you do... I don't think you can. Rotate left on an address. You can. So I don't have to do... That's interesting. So... we don't have to do that. We can actually... Well, hold on a second. Before... let me comment this stuff out. Let's fix that, because I didn't realize you could do that. So we don't actually need to. You can say rotate left temp 2, and that should take care of what we want, because we're loading it, rotating it, and then storing it again, which we don't need to do, it looks like, and that should save us some time, assuming that that works the way I think it does. Let's see here. Yeah, it looks like it does, because that's what we're doing with the controller, and I had forgotten, just because it's not... Still not remembering all of the opcodes. So then there was another thing I was thinking about the other day, like if we're doing a transfer X to A and then a store A immediately, we don't need to do that. You can store X and store Y. That's a push, that's different. Transfer X to A. That's okay. That's okay. Alright, that all looks okay. What about transfer Y to A? Yeah, that's just for when we're... Oh, so here, like in this case, right? We're doing a store A of this, and then we're doing a transfer Y to A just to store it here. You can actually do this. Not that that is going to make or break the game, but might as well. Let's see how that looks now. Everything still appears correct. Okay. Good. So, no scope camera. This is why pause. I keep forgetting that. That's the other thing. Camera plus camera, like that. Okay. So we don't have to do that. We can say store A, that, then shift it and store it again. The only reason I'm doing that is, yeah, it's not necessary. Okay, so we shift it, we store the shifted value, we rotate it into this. So that's one time. And then actually, well now, that's interesting. So we don't even have to do this until the end. We can shift it and then rotate it left and then shift it, and we only have to do the store at the very end, right? So that's 1, do 1, 2, 3, 4, 5, right? Multiply by 32 to calculate maximum Y position based on number of rows, right? And then we have our camera position in terms of world coordinates. And what we then want to do is we want to set the clear, we want to load A, well, let's load A with camera plus camera, Y pos. We're going to set the clear and subtract, how many rows? It's 7 metatile rows, which is 32, 200 something, 7 times 32, 224. What is that in hex? EO. Subtract EO. And then branch if carry is set to the next label, and then what we want to do is we're going to decrement camera Y pos plus 1, because if the carry is set, then we didn't underflow. We didn't go from 0 to I'm doing a bad job of explaining this. Let's say we had a value like 80 and we subtract E0. You see how we get this. The only part we're going to see is the A0, so we need to take our other or more significant byte in the 16 bits and subtract 1 because it's a 16-bit value. And that gives us our starting position for the camera. So what we should end up with is 100 times 32 minus, I'm doing this in decimal, in hex rather than decimal, so it's 224. So 100 times 32 minus 224, so we should end up with 2976, or BA0. So camera Y pos plus 1 should be the value 0B, and A0 should be in the lower position. So let's make sure that that's actually true. Debugger, assembler, no, not that. Disassembly, where are you? Okay. So this is where I want to stop. So camera Y pos B80 3200 minus 224 BA0. Was my math off? Well, obviously it's off. I'm just not sure why. Let's maybe, you know what, it's possible we didn't, the number of rows, I am incorrect about the way that's stored, but let's see. Thought it was 100, but yeah, that's 100, so store it, and then we shift it, and carry is clear, so I wonder, well, no, the memory should be zeroed out from the beginning. So let's see, camera is at 68, which is here, so it's 0 and 0. So we rotate on that carry, nothing happens. We shift left again. This time carry is set, so we're going to shift it back on. So that's there. That's good. Shift again. It's set again. Shift again. Set again. It's not set this time. Okay, good. Shift again. It's not set. So now that's C100. So did I not shift enough times? Did I only shift 1, 2, 3, 4, 5? 2 to the 32nd, 2 to the 5th is 2 to the 4th is 16. I thought that's right. Two to the 5th, 32nd, 32. 2, 4, 6, 8. No, it's not enough. 16, so we need one more. That's multiplied by 2. That's multiplied by 4, by 8, by 16, by 32. No, I have that right. What am I messing up? I just didn't store that, so let's take a look at what that actually did. No, that's right. Okay, C80. I don't know why I thought that was wrong. C80 is 3200. Okay, yeah, that's right. Okay, sorry, it's been a long day. So we have C80, and then we're going to subtract E0, which is 224. So we're going to, we loaded that into A, and we set the carry, and now we're going to subtract E0. Yeah, so we're going to subtract 80 minus E0. We get A0, which means that carry is clear. So now we're going to take the C and decrement that back to B, right? That's B80. Oh, except that it helps if you store that. So I didn't actually store the result of the subtraction, which is why that was wrong. Excuse me. Right, 3200 minus 224 is BA0, and the A0 part is in here, which I didn't store, so that's why we're seeing B80. Okay, well, silly mistake. So I don't have to walk through that all again. Store that, and now BA0 and BA0 is what we want, right? BA0, so 2,976. So that's the absolute position of the camera, and what we need to do is we need to position the player's Y coordinate accordingly. And then when we are writing the what's it called? When we're writing the entity to the sprite memory, we do the subtraction to put it back into screen space. This is the same thing that you do with 3D graphics in a certain sense, because you know, you're always working in the 2D space on your screen, but you know, you're taking these coordinates that are dealing with, you know, things that are unseen, and you know, in 3D you have the you have the volume that you're working with for your screen, and you have all the stuff around, and you're using a transformation matrix to kind of boil it down to something that can be projected onto your 2D screen, and all of your coordinates start off. If you're, well, you could decide not to do that, but the 2D, all of your things exist in world coordinates and have to get translated accordingly to your position and the camera position into screen coordinates to be rendered out. So it's same process, but less work because we're not doing 3D graphics, so there's no like floating point type calculations and trigonometry to bring it down into something that you can render in 2D. All right, so initialize entities. Where is it initializing the player? Load new game state. Initialize. I guess this is it, right? Because that's the X position and the Y position. The X position is fine. The Y position, I think I changed that, right? To be a word. It is. Okay. Misspelled that. Where is that code? Here it is. So the Y position, right now we have it at 78. But realistically, what we want to do is we want to say, so this is our current position of the camera. And we want to add enough to make it centered. So we want to add 120. So that's C18. So what we want to do is we want to store 18 there, and then store C. Now, of course, this is going to be This is going to break the enemies, but that's okay for now. I want to start with just getting the player working. Of course, now let's see what else would break. All of this adjusting for the velocity is going to break too. Let's just out of curiosity see. Well, one thing we have to do is with the asset tool, I think we have to change it so that begin populating the OEM data in memory. So I think draw entities is yeah, so it's using the XY information in the, all right, so that's fine. We just have to change how we write this code out. So right now, what we're doing is we're just writing the code out without doing any work on the Y value to translate from world coordinates to the screen coordinates. And what we need to do is we need to take into account the camera position. So what we would do is we would load, let's see, how do we do this? That's the blaster. I don't care about that right now. I want to do this for the player. Trying to think of what's the most efficient way to do this, because we don't want to recalculate it for every sprite or every sprite offset. So what I think we probably will do, because right now what we're doing is we're taking the Y position that's literally in the entity and using that to calculate the position of the 4 sprites that make up the player. But the problem with that is that we then would have to offset that Y position every single time. So what we really want to do is we want to say this, and then we want to actually, maybe what we want to do is the camera position is always going to be ahead of the player. So what we want to do is we want to say, okay, load the camera plus camera Y position, and then just trying to think of how we need to deal with the subtraction of the 2 parts. I guess we would subtract the higher order bytes and then the lower order bytes. Let me think. If there's a carry clear after subtracting the lower order bytes, well, there shouldn't be, because, well, actually I got to reverse the order. I had the order right, because even though the camera is always going to be on the screen positioned, you know, above. If this is the player, the camera is always up here, so it always has a lower value of Y compared to the player. So we want to take the player's position and subtract the camera. So we don't have to worry about the carry on the higher order byte. So let's see. So we would do this, and then we would set the carry and subtract with carry camera plus camera Y position plus 1, and then store that into temp2, and then load A entities plus entity Y position X, and load then set carry and subtract camera plus camera Y position plus 1, no, Y position, and then store that into temp, and then branch if carry is set to the next label, and then decrement temp2 here, and then this is our next label, and then instead of doing this we would just load temp, because we don't need temp2 for anything other than keeping track of where we are in the screen. Ultimately, the lower order byte is all that matters for the actual display, because if it's out of the bounds of the byte, then it doesn't display properly anyway. A bunch of stuff is going to break by making this change, it looks like. Hey, Dasani Fresh, thanks. You're welcome for sharing it. I'm just kind of trying to go through this, you know, as best I can, and hopefully it's useful. Just kind of, you know, sharing what I know, and sharing the learning process, because it is something that I am, you know, teaching myself the NES programming part as I go. So we all learn together. So that's good, because that didn't break anything, which I thought for sure it would. scrolling is, so the positioning is wrong in terms of what it's where it's letting the player scroll to, or move to rather, but that's actually not as broken as I thought it would be. But I think also the other thing is we're not manipulating the camera at all. So let's do that in the game loop. We know that we need to if we are in a game play state, we need to reduce the Y position load new game state, gameplay state. Okay, so load A, camera Y position. We're doing it this way because we want to see if the carry gets cleared when we subtract. Actually, do we care about doing it this way? Yeah. Subtract 1. It might be easier to just... It might be better to just do this. We decrement it after we load it. And then we just do this to check and see if the carry got flipped. Branch carry clear. Branch carry set to next label. And then we here decrement. Camera Y position +1. That actually might work better because otherwise we're loading it, we're decrementing it, we're subtracting it, then we're restoring it. This is just more straightforward. There might be a better way even yet to do that, but I'm okay with this for now. So now let's see if that broke anything, because now we're actually changing our Y position. So let's look at the camera Y, which I think is over here. Yep. So let's see what that looks like. So the player's sprite is being forced down as the camera position is moving. Oh, right, because the player doesn't have any forward velocity. So this is the thing, like as we start bringing in real world concepts, you suddenly realize, oh, well, we forgot to do something. So because we were just basically faking movement before to some extent, we were scrolling without doing anything to the player because I don't know if any of you guys have ever watched Futurama, but there's an episode where the professor talks about how the space shuttle works, where it doesn't actually move faster than the speed of light or something like that. It's that it instead of it moving fast, it's able to move fast because it moves the universe around it. So that's kind of what we were doing. We've got this ship, which is our sprite in the middle, and what we were doing is we were moving the tiles underneath it and scrolling, the tiles underneath, but we weren't applying any sort of forward velocity to the ship. So now that we've made it so that this motion of the camera is actually moving through world space, what's happening is the camera moves, but the ship has no velocity, so it's not technically moving anymore. It was never really moving. It was just an illusion of the way that the background was working. So what's happening is it looks like it's falling behind because it's not moving in its Y position at all. So we actually have to apply a constant Y velocity. That's kind of funny. I didn't think about that. I'm wondering if wonder if we just add done checking directional. So we're doing that. Process player. So I think, let's see, where are we actually doing? Skip forced velocity, skip Y position cap, process player velocity done. So no matter what, we want to increment or decrement the Y position of the player so that it continues to move through space with the rest of the, there we go. Now, this is going to be a little bit wonky because of the fact that we are, I think what we're going to end up doing is we may end up storing both the relative screen positions, the screen positions and the world position, in order to calculate the way, or we may have to rework this to make it work appropriately, because what's happening is now all of these calculations that we did are technically wrong because they're looking at the world position. So like the X changes, that's all good because the camera X position is always the same, right? We don't have any issue because we're not scrolling left to right like we are, but we are scrolling up. And now that the ship is actually moving, this Y velocity calculation stuff we're doing is based on the Y position. It's not based on the world position of the ship. And so, I mean, we could do the same thing that we're doing when we are rendering the sprite out, but at the same point, it seems like a waste to recalculate it every time, or recalculate it twice. And we could have a world position and a local screen position. I'm not sure which is better. And by the same token, we still have to do our calculation where we say, okay, if the player position is, what did we say it was? Is that it? C18? Yeah, so if the player's position is C18, we then need to divide that by 32 to find out what metatile row the player is on, and then look at the X and Y position on the map and determine, is that a collidable? We say, okay, we look at the metatile that's there, and then we look at our metatile collision buffer to see if it's a collidable metatile. And then we further have to look into the metatile bytes and see, okay, are those tiles in there that we're on, are they the collidable part of the metatile? So I'm thinking what we want to do, because the memory, we're still doing okay with memory, I think. We have our Y screen position. This is world position. y screen position, x velocity. Okay, so I'm almost wondering if it makes more sense to change this back. And the reason I say that is because we have all that stuff working already using Y position. Let's, if we have less to change if we leave that alone and make this instead. So that's the camera. This is Y world position. And then what we still need to do is we still need to, what was the value we were storing? We still need to store the screen position, although it'll probably get recalculated anyway, but just for the sake of kind of making this complete, 78, right? And then when we draw the entities, now obviously I'm changing this in here, but realistically we would want this to be generated by the asset tool, because the asset tool is what's doing this, writing out this code for us. Camera doesn't have YW position, it's always in world position. Alright, so that's YW position. Blah blah blah, stored in there. Camera that, blah blah, decrement, jump. Okay, and then what we would want to do, well, no, you know what? I take that back. We want to move this. I want this code. Let me put this over here. Want that code, but what I really want to do is I want to revert this back, because the Y position is now back to what it was. And what we want to do is in the processing of the player, we want to update the Y position to reflect screen position. So this is sort of cheating, but it's okay. It's sort of cheating, but it's not, because basically the idea that we're bounding the player to this arbitrary screen that we're looking at it on, if you think about it, it has no meaning in world coordinates per se. So what we really want to do is we want to boil that down to the screen coordinates, and then do all of our processing of the bounding on the player based on the screen coordinates. Now that's not true with the velocity, but for the sake of just getting this working for now, let's pretend it is. Ultimately, the velocity should apply to the world coordinates and not to the screen coordinates, but that's okay for now. So we're going to load the Y position, the world position, and modify the whole camera, or use the camera to generate that, and then we're going to load, well, we don't want to store that in temp2 now, we just want to say entities. Actually, that's okay. store that in entities plus entity y position, and then we don't care about that. So offset player by camera, that's actually going to be, you know what, we can apply that at the top because pretty much every entity is going to need that. And again, I realize this is arbitrary in a certain sense because this is doing this offsetting into y position and then applying velocity and stuff to that screen position, but we don't necessarily care about that right now. So the good news then that means is that we don't have to change how draw entities works because it's going to always have the right coordinates, doesn't have to recalculate them. So let's see if that, yeah, we still have, okay, hold on. I forgot, I took out the part where we are incrementing the world position. Where is that? Process player XV done. Skip that, skip that, skip that. Process player remove X. Skip position cap player. Velocity done. Okay. So let's get rid of that there. We want to apply that to the world position. Decrement. So in this case, we do want to track this properly. We realistically should be doing it through velocity. We can say that the y velocity is always, forget which way. I think I have y velocity pointing up. Oh. This isn't going to work exactly. So the reason this isn't going to work is because it applies the transformation to the y velocity and then, well, it'll sort of work. It applies the velocity to the y position in screen terms, but then it doesn't sort it back into the camera position. So that's all right. Let's cheat for now. Let's cheat for now. So let's we're doing the subtraction here. Sorry, I'm thinking about how I want to do this. So we're going to load this, and then we're going to also decrement it, and then set carry. Same thing that we were doing before. Branch carry clear, branch carry set. Come on. To the next label. Otherwise, we're going to decrement. And that's the label. And I'm just doing this so we don't have to do this extra stores. What is that? 1215. Yeah, I spelled that wrong. Okay. I'm not even sure that that's exactly right. Yeah. That's new. Are those, you know, oh, wait a minute. Those are other sprites. They should not be doing that. Okay, that, yeah. My mistake. I forgot. there are going to be entities in that that are not subject to being processed because, yeah, because they're not really entities. Let's fix that. Okay, good. That was what that garbage was. I was kind of like, where did that come from? How did we mess up our attributes and name tables, but we didn't. Okay, so this is fine. We can see that I can't move up and down anymore, but it's because we broke that motion by not really using velocity to move forward per se. But the point is, I want to be able to have this in the right world position so that we can set a bit or a byte that says we've hit a metatile that's collidable, and then we'll wrap it up here. So, hey, Relrita, it's going. You're making progress. All right, so now that we're here, I guess what we want to do is we want to. Where did we check the collisions? Check collision with other entities. That's the bullet collision, process player, velocity done. So we're not doing, okay, so we don't have any of that for the player yet, right? So now, this is actually pretty straightforward. What we're going to do is we're going to take the player's X and Y position, and we're going to divide it by 32 to find the position in the map. And the reason we're dividing by 32 is because the map is consisted of 32 by 32 metatiles. So we're just scaling it back down to the scale of the map from the world position. And we're going to use that to then look into the map and find the metatile that's at that location. And then from there, we'll know, based on we have the metatile collision data, we'll have the offset to look up whether or not that's collidable. And all we have to do is there are 2 bytes, and we look at if either of those 2 bytes are not 0, and then we'll set our little collision victory flag here. So we'll say player collided. We're not going to keep this, but just for something that we can actually look at. 1 if the player collided with something on the map. Okay. So process player v done. Okay, so let's see. So we're going to load. So yeah, we need the X position is the simplest because we know that that is already essentially in world coordinates and isn't going to be big and doesn't require any sort of crazy 16-bit math. So we just divide that by 32 and we get what we get. So we load that, and then we're going to do shift right 5 times 2, 4, 6, 8. Divide by 2, 4, 6, 8. No, 2, 4, 8, 16, 32. Not by 2's, by powers of 2. Right, and then we store that into temp. And then we're going to take, this is where things get a little bit crazy. So we load that into A. And we want to, I forget, is it ASR, logical shift right? What is it? LSR, I think that shifts bit 0 onto the carry. 0 is shifted in, and the original bit 0 is into the carry. Yep. So we do logical shift right, and then we do a rotate right on glad I discovered we can do that without, or remembered that we can do that without loading it and storing it, because it's much more efficient to do it that way. So we're rotating it right, so it's going to take all the bits and shift them over by 1. It's going to take the carry, which was shifted off of the most significant byte, and put that onto this. And then we're going to do another one. So we're just going to keep doing that, right? We're going to do that 5 times. Oh, wait, no. Damn it. Almost. Load A, entities. We don't want to actually do it to YWPOS. We want to store it in temp2 and then do it to temp2, which is better. Okay, that's better. Nope. Sorry. One, 2, 3, 4, and then 5. That's divided by 32 now. So let's see. So we have the most significant byte and the least significant byte here and here in temp and temp2. Oh no, I'm sorry. This is the X, and then this is the least significant byte, and we're going to ignore what's in A because we know it's going to be within 255, so that's fine. So we have X and Y here now in temp and temp2. So let me write that in because I'm going to forget. Temp is X and temp2 is Y. And then what we need to do is find the location in find the location in the map. Yeah, you know, I haven't worked with a lot of Z80, but it's no surprise. Most assembly looks, you know, sort of the same unless it's using sort of a crazy syntax. You know, x86 assembler is sort of similar syntactically also. You just got to get used to remembering what the opcodes are, what the opcodes are, because when I first started, I kept trying to use, you know, like move and some of the other x86 assembler opcodes, but it's not. It's you get used to it, and I'm still learning what some of the opcodes are because you know, you don't do it every day and you forget. So the map is where? The map is, there's ROMEM, but let me see. I think it's ROMEM for, it is. Okay, so ROMEM has the position of the map. Now the problem might be, yeah, so ROMEM is getting changed as we scroll. So what I want to do, I'm going to create another thing here called level mem, and basically that won't change. That's going to be the beginning of the level that you're dealing with. So just use through scrolling and changes. This always points to the beginning of the level data. Okay, so that's good. And then let's go to here. So now we can use level mem to do our lookup, right? Yeah, the ZX Spectrum or the ZX Spectrum, depending on how you prefer. I don't know. I'm not British, but I do prefer hearing it as ZX Spectrum. Looked like a cool machine. Never programmed for it, but pretty cool what it could do. The old machines are interesting to program for. The Nintendo itself is, you know, kind of along those lines. It's a very underpowered system in some respects, but has a lot of cool things you can do with it. Let me think about how I'm doing this math now. So y has to be multiplied by 8. Load A temp 2, and then shift ASL 248, and then we want to clear the carry and add temp. That gives us our offset into level 1. Yeah, into the level. And then the thing is, we need that. Are we using Y for anything here? I don't think so. So transfer A to Y. Load A with level mem Y. And then that's our metatile. So let's make sure that we're getting the right metatile information here before we try to figure out why, for some reason, the byte isn't getting flipped the way we expect it to. So let's go back into the debugger. Load, let me go back to the source mode. Load a level mem, here it is. So are we hitting the breakpoint or what's going on? Oh, is it paused? Yeah, okay. I didn't realize I had paused the game. So what we should see is at some point we're going to hit a metatile that isn't 0. And A should reflect that. It looks like it's not. Why is that? So the entity world position. Let's see what we've got here. So temp has 4, which that looks reasonable. So A has D6. Store that in temp 2. So D6 and B, so B D6. So we shift it, carry is set, so temp 2 is now going to carry that value on. We shift it again, and carry set again. Shift again, it's not set. Shift again, it's not set. Shift again, it's not set. Temp 2 is now 5E. 5E in hex is 94. That's actually very reasonable because the height of the map, or the size of the map, is 100, right? So now we have our Y, which is 5E, and we're going to multiply it by 8. Oh, are we going to overflow? Is that what's going to happen? 5E times 8. Yeah, we're overflowing. How? Bleh. Really? Yeah, I guess so, because if it's 100 times 8, then yeah, that's, so that overflows. Or it doesn't overflow, it doesn't fit in a byte. So temp is not going to work. Temp 2 is not going to work for this. Could use adder param. We'll use adder param. Sorry, I'm just thinking about how I want to do this. So we're going to load that, and then we're going to shift it left. Just confirm ASL sets the carry. So we rotate left on adder param +1. And then we're going to clear the carry. We're going to add temp, and then branch carry set. Branch carry clear to this, and if the carry is set, we need to increment adder param +1, because the increment of the value plus temp also caused a carry. What's the problem? Adder param. Adder param 1. And then we actually want to do okay. Then we want to do load a adder level mem clear carry add carry adder param 1 branch carry clear increment level adder, I keep spelling that wrong, adder param +1. So that's that. So we're loading level mem and we're adding adder param 1 to that. And then we're incrementing that part and then store it back into adder param 1. Then we're loading level mem +1. And we're going to clear carry and add carry adder param 1 +1. And then we're going to store that back into adder param 1. And then we're going to load A with adder param 1. Yeah, and then Y is just 0. Can you do that? Can you just do load A with an absolute and no? Yeah, you can. Is that loading? That's the address. So that should work, right? No, that's loading. It's kind of silly. Load Y with 0, and then we're just using that as a pointer essentially. All right. You don't think about all this stuff when you're writing high-level code. You just kind of write it, and it happens, and you go on your way. But dealing with an 8-bit system like this is a little bit trickier by comparison. because then you have to kind of manipulate all the 16-bit stuff yourself. Okay, so actually I want the breakpoint here because I want to just see the result. So once we get the top left corner of the sprite over the blue part, we should see A have a value that isn't 0. No, it's still not working. Okay, what did I mess up here? So up until this point, the value is, it seemed like it was okay. Oh, I wonder if adder param is not initialized properly, and that's what's messing it up. Yeah. All right, so initialize your variables. Keep spelling that wrong. All right. So that's 0 now. So let's see. Yeah, that looks better now. Now we're going to do some math on it. Why did I do that? That is the wrong thing to do. That's a holdover from before. Store a adder param1. So we need to store that. Okay. I'm also getting tired here. Hopefully I'll get this working before we stop the stream. Try not to leave things broken. All right, so let's see what we end up with here. 304. I think that's what I saw in the calculator. We'd said it was 100 minus 8. Is it 96 times 8? Yeah, that's close because that's 304 hex, so that looks okay. So then load A, clear carry, add this, no carry, so store it. Load that, clear carry, add, yeah, okay, no, that's fine. Oops. Store that. So now adder param is at what? 3EF. That's weird. E7 EC27. Oh. Dumb mistake. Right? That should be, yeah. That was just a dumb mistake. All right. So that's fine. This is the part I'm interested in now. Load, clear, add, store, load, clear, add, store, EF2B, load Y, load that. Why is this? Oh, there's a breakpoint here for some reason. Okay, so let me restart this and watch what the value is. 0, and then it's going to go to one maybe soon. It's weird. It's not. It was showing a value that wasn't 0 a moment ago. Let's see. Of course, nothing is on the screen yet. Let's see, level mem is set to EC27. So if we're at EC27, right, and see you later, Rita. Thanks for watching. EC27, and we said that it's like 96 times 8, roughly. Oh, right, and then it's like halfway into the screen, so plus 4, so 304 is what it should be. Let's see, temp, that's 4. Yeah, okay, so that's fine. So it's 304. So if we take that and we say it's 304 plus EC27, EF2B is what we should have in adder param, and we do. And if we go to the memory there, okay, that's weird. That sort of looks like our screen, right? EF2B. That's actually, It's everything like offset by a byte, so it just perfectly wrong, perfectly doesn't line up. Where's level mem start? What did I say? Level mem is EC27. Yeah, so it's it's just ever so slightly off, so it doesn't visually line up the way I wanted it to. Okay, so EF2B, EF2B. I mean, that looks like that should work. Right, so we went, EF2B is here somewhere. Where is that? EF2B. It was here, I think. Yep. So then the next spot it would be EFEB. EFEB. Is that here? EF2B. Why is it higher? That's weird. EFEB is over here. EFEB. Should I read that wrong? No, I did. EEEB. That's EEEB. So it was here. Well, no, it wasn't. That's EF2B and then EEEB. Also, why? Let's see what the... So it should just be going down by 8 on every row, which doesn't seem to be. Does this not refresh? Guess not. Or is this showing? It's showing the address of controller rather than the value. That's my not understanding. 60 level mem 6e. So it's showing the. How do I see the actual value of the thing, and not the? Well, all right. So 6e. It's weird. It's odd that it does it that way, but okay. Not that big a deal. Let's restart this here. I want to step through this a little bit more. So what we should see is that 2B should be going down by 8 every metatile row that we cross, except that it's not refreshing that thing. So if we have EEEB minus 8, which would be EE3 in a moment. If I've done this right, which I haven't, but I want to see what it actually ends up becoming. It's not actually changing? That is weird. Where's that location? That's 88. All right, what's the problem? So we're loading the X position, we're loading the Y world position. Is the Y world position not changing? I mean, if it's not changing, no, that's changing, right? I don't know why I'm storing that there. Oh, yeah, I need it for, that's why I need it for over there. So right now the value is 0, which is odd. Oh, I guess not, because the Y world position is B0, I guess. Let's see. 7A. B7A. So B7A. And then we want to right shift it 5 times, and that would give us 5B if we did it right. 5-8. Something is wrong. I'm not sure what got messed up here. So temp has the position, that's fine. So A is 17. Oh, you dummy. So here I am loading this value and storing it, and then I'm zeroing it out. And I wonder why it doesn't work. It was a rhetorical store. Okay, so A is 17, we store that in that. We'll load that into A. And we shift, and rotate right, and shift, and rotate right, and shift, and right, blah, blah, blah. So it was C. Well, and then we do this. Let me restart it, because I didn't really, I forgot what the initial value was, and I want to make sure we're calculating it right. So it's 17, C17, C17, right shifted by 5, so we should get 60. And add a param, and we did. Great. And then we're going to load it, and we're going to multiply it now. Then we're going to left shift it 1, 2, 3, 1, 2, 3, 3 times, right? Because we're by 8, so we should get 300 as our value for adder param. 360. Load A. Okay, it's 360. That's fine. Okay, yeah, because we're adding temp, which is 4. The carry didn't get set for that, so now it's 304, right? 304. That's correct. So now we're adding that stuff in, and the value we get is 1. And EF2B, and let's see if we continue to get values that make some sense. Let's go to memory, and header param is at 88. So I think the position that we're using is off somewhat because it's showing that we're on these blue tiles already, I believe. Well, let's see. It's at least changing more like what I expected. Do we ever get the 4 tile? Looks like we're just getting 2s and 0s. I mean, it's obviously something is not 100% map lining up here. Let's see. If I had to guess, I would say it's probably the world position, the sprite position is not exactly right. So, so the screen position is 78 in hex, which is 120. So it's smack dab in the middle of the screen, which has 7. So 100. Well, 78. So 120. 3. So we're 3. So 100 minus 4. 96. Times 8 plus 4. 304. No, that's not right. We're at 100 rows, right? 100 rows times, so 800 metatiles. And I want to be halfway down that. So I want to subtract 24 from there, and then it's actually not exactly that, because then you have to add in 4 more. So it's 3OC. So I guess this is probably wrong. Why did I have C18? 3OC. What's C18? C18. Oh, right. Because I was doing it based on just the pure. I was doing it based on purely just the pixel coordinates. So let's see. If that's 100 at the bottom minus 7, that's in hex. 100 at the bottom times 32. Let's do 100 minus 7 times 32 plus 120, and then that's C18, but the x coordinate is wrong. What's it in hex 8? It's 128 plus C18, C98. Maybe that's why. Let's see. I think the starting positions just didn't line up properly. So let's see here. What's the matter? So now it's not offsetting it properly and showing it on the screen correctly. know, the other thing is, I didn't think about that. We also have the remapping of the tiles. The tiles are renormalized. I forgot about that. So the values that are coming up there are the values within the map. They're not the value of the metatile globally. Here's level 1. So forgot about that. What is it? It's over a number of rows, and then we have the palette loop. So we have our 4 palette numbers, and then we have 0, 1, 2, 3, 4, 5, 6, 7. Let's see. Compare to 9. Right. All right. So there's the sprite lookup, metatile lookup. We're not doing metatile. So that's that. Transfer A to Y, load A, metatile lookup Y. I forgot we have to do that. Okay. So now we're going to maybe start seeing values that make a little more sense. Fix the starting position. What is it at 60? 60. So I change this. I have a bunch of memory windows open. So what did I say? I said it was 100 minus 4, or well, what should it have been? 100 minus 4, so 96. 96 times 8 times 32. No, try again. I think I just did 3200 minus 120, C08, and then you got to offset it by your x coordinates, so C88. Let's see if that fixes it. No. Where the hell is the sprite? It's on the bottom of the screen. All right, let me just. Where is the camera position set? So it's set by taking 100. Times 32, and then subtracting E0. And what is E0? It's 224. That's 7 rows of 32. Is that what that is? 7 rows of, yeah. Multiply by 30 to calculate, subtract, I should put a note here. Subtract by 7 rows of 32, 224. Okay, so if that's what calculation we're doing for that, then 32,000 minus I want to do that minus 120 and then plus, that's 240. Oh, wait a minute. Is that why it's not working? Yeah, that's not, of course that's not going to work. So it's 32,000 minus 120. So it's 7C88. Right? Because it's 32,000, 3,200 pixels. 3,200 pixels minus 120. C08. Sorry, I'm getting tired, so I'm making dumb mistakes, and you get to watch and laugh at how dumb they are. Alright, let's rebuild this and restart. Okay, so now it's in the right position, and right now we're seeing that it's saying that the tile is 0. We're still not seeing the right. I think the positioning is a little off. It's definitely traversing the map in some capacity, but something about the way that it's being done is off a little bit here. I really don't want to stop in the middle of this with it not working. What are you doing, Messin? There we go. All right, so let's try this again here. So the player's current actual position on the screen is 128 by 104. Now, if we go to the memory of the game, well, I don't have to do that. Entities is at 91. I just got to look back at what so X position, Y position, and then the world position. So X position, Y position, and then this is the world coordinate, 40C. So let's see, so 40C that's really low already, isn't it? Because the map was at 40C, or is it CO4? Yeah, that okay, it's CO4. That makes more sense. Oh, right, yeah, that's right. That's what we initialized it to. Right, makes more sense. Okay, so CO4 And if you divide that by 32, if you're doing it in decimal, you get 96. So 96 plus, and then the X position is just that one byte, 128. And that's divided by 32, and that gets 2. So it's 98. That's not exactly right, is it? Let's see. 1, 2, 0, 1, 2. No, it's more like 3 or 4. Why? That's odd. Where's the breakpoint? So, what's the deal? What's the deal? This would be easier. So, I mean, this is right now because it is 0. But when we get over here, what I expected to see, because the sprite is right over there, is that that should change. EF1E. I mean, that is the right, I mean, it's reading the right thing, but it's not the right value. It should be this row of 2s, which are the blue, tiles there, and then in, did I close the hex editor? I did. In the lookup, it is, let's see, 1, 2 is 2, which in the metatiles, 1, 2, the blue tile, yeah, so that's what I was expecting to see. But obviously, that is not, something about the positioning is not aligned with what we're seeing. And I guess, so if we take, take the entities at 91. The Y position is BDA, right? That's the Y position. And then our camera position well, you know, that doesn't even matter really, sort of. I guess it, I wonder, Sorry, I'm trying to figure out, there's a discrepancy here between maybe the way that the level is loading versus what we're calculating for our start of the camera position and the what's it called? And the sprite position. So when we load the map initially, we're taking the row mem, right? Or the row count. What did I call it? Max rows. We're loading it and we're subtracting 7 rows from that. And we are using that to load the map. So that's 7 metatile rows, which is 224, which is a little bit bigger than the actual map, but that's okay. We go through and we load the tiles, right? And we do it until we get to 1E. 1E is 30. So we start at 7 rows back from the max. So if the max is 100 rows, we say, okay, at row 93, that's where we're starting. So the camera, similarly, should be starting there. So that's BA0. So we're kind of working it backwards, but we're saying if it's 3,000, we do that, that's 24. So that's actually not what we're calculating. We're doing, if we do what is E0? 224. It's 224. What am I doing wrong here? 93 times 32 BA0. It's 24 pixels. That's not right. "93 rows of 32 pixels. What's so hard about this?" Oh, it's 3,200. 3,200 minus that, 224. So that's E0, right? So 3,000 3,200 minus. I wonder if I'm using 3,000 in my calculation accidentally because I'm not paying attention. Okay, so that's fine. Now the player, 3,200. 3,200 minus 120 is their y coordinate. E, right? Except you've got to be in decimal. C08. That's what I'm doing. So 120, right? and then the regular Y position is just 120, which is 78. So that's fine too. So what's going on? The X position is 128. So it's 3200 minus 120 divided by 32. Damn it, I'm not. 120 divided by 32. $96, right? And then there's 96, and then that's 120 divided by 96. So that's, oh, so that's why. Why is that? 80 in hex is 128. 128 divided by 32 is 4. That's 4 across. Right? Yeah, so 96 times 32. Six rows of C78 divided by 30. 20. That is wrong. Why is that? 300 minus 120. Because what? Because it's 100. It's 100 metatiles. So that's 3,200 pixels. I'm mixing up my units here. C78. That's the world position, but yeah. Oh, okay. Hold on. If I divide that by 32. That's strange because 3168 3200 minus, they're 32 pixels across, right? So but that's not even what I'm trying to do. I'm trying to offset it by a Y position that has nothing to do with the X position in there. So if the ship were at the bottommost part of the level, which is 100 metatiles, 100 metatile rows, then 100 metatile rows is 3,200 pixels because it's a 32 by 32 metatile block. So if it's 3,200 pixels, the screen is 240 pixels, and I want to scroll down half the screen, it's C08. Why did that? Okay, that's what I have here. Was I doing 7, 8 accidentally? Maybe. Divided by 32, that gives you 96. Okay. And that's what the Y position is, right? No? No, it's not. The Y position is 78, which is 120 in hex. 120 in decimal. 3200. That should line up. I don't understand. This is what am I doing wrong? So it's just losing it here. Load 80, store that. 08. Wish this gave the actual value of YW POS, which is, let's see, CB address 91. Why do I feel like I'm... That's the low, and that's the high. So the high byte is +1, right? So it's C08. And C08 is 3200 minus 120. So that should be right. The X position is 80, which is 128. It's 256, which is fine. If you double that, that's the center of the screen. I'm running out of patience here. So sprite is at 128 by 104. If we calculate this, DEB, where's this stupid camera Y position? It's at 68. Actually, I just take the value. B83. We should get the same value for the position, 104. The Y position is exactly the same. So the camera offset to the sprite is correct. So is the lookup wrong? What is the deal? Is the level position wrong? Level mem. You know what? It probably is, now that I'm thinking about it, because I wonder if it's being offset the same way that row mem is. Oh, damn it. So I forgot that at the end we reset row mem to point to the actual position that we have the beginning of the map. No, that's not where it points. It points to the location that we were last done with the map so that we can start loading the new tiles. So where, let's see, so sprite mem, so this is where we begin. Okay, so I'm correct that the values of level mem are wrong, but for the wrong reasons. So it's wrong because we're not skipping the data that comes in the beginning. That's easy enough to fix. So let's see. So 9 is the offset, right? There are 9 bytes of data. So let's do that here. So load a level mem, clear carry, add carry 9, branch carry clear to the next label, otherwise increment level mem 1. There's our label, and then store that into level mem. That, I think, will fix it finally. Let's see if this starts to look more reasonable now. All right. So Y is getting a value of 2. That seems, or had a value of 2, which I guess is the bumper. No, it's the blue. That, okay, so this is almost right. It's probably because I'm looking for it to be over here and it's really like over here. And that's probably, let's take a look here. So 1, yeah, 1 is the bumper. So it is slightly off, but it's way better. It's actually mostly working now. If we look at 1 is metatile 4, which is the bumper. Okay, cool. So that's actually working now. Except that the X position is off. Not sure why. Oh, you know what? It's probably because the sprite is just kind of happening to fall incorrectly over the metatile. Can I highlight it with mouse over, or it's showing where it is on the screen? It would be cool to show it. I gotta request an enhancement because it'd be cool to be able to see the sprite location on screen, on this part of the screen, versus over here, because then it's hard to match up like where that actually lives. I think what's happening is that the metatile is actually over here. I mean, it's technically right. The metatile has a lot of white space on it. Let's go look at the metatile. Where's the bumper? So it's got a decent amount of extra space here, and because of that, the X position being over here rather than on the nose is kind of throwing us for a loop there. So if we assume that we're looking at this point here and it's getting this, let's watch it and see if when we get to that blue part it actually has a value and why that makes sense. So when it gets to the blue value, we should see it change to 2, I guess. And it is. And then it should go to 0 once it hits this spot, and it does. All right, so I think you can you rewind? There's a way. I think you can with the triggers rewind. Oh, but it's in debugging mode. Okay, so I just want to kind of make sure that it's really that transition like I'm thinking. 2, and then like once we get to right over here, it's a little bit further up than I expected it to be. But I guess there's, again, a lot of white space over here. Yeah, but the nose of the sprite comes up all the way to the top. So there's some fine-tuning we have to do. And then, of course, the other problem with the way that this is working is because of the shape of the ship, you can kind of begin to see that there are going to be obvious problems related to the way that the collision detection happens. Even if we just make the nose portion what we're checking, you're still going to see problems where it thinks it's colliding, where it doesn't show that it's colliding, but it should be, because the wing is, you know, over. Let's say we're let me do this. So break this and that. So like if we are flying here and the wing flies over there, or over, you know, like the wing just clips that, that's not going to get detected, because again, we're only using the top left corner for the level. So that needs to be fixed. And then I think the up and down movement is still broken because we're not using the velocity to adjust the ship up and down. Yeah, so there are a few things that need to be fixed for the next stream because of the way that we changed. This ended up being a lot more changes than I thought, and the fact that I was messing with the level, I had to create that the level memory position for the map. I forgot that it was pointing right at the beginning of the file, which has that metadata about the map in it. So that didn't work out the way I expected to, and it was causing some weird issues. So for next time, what we'll do is we will set it up so that in the process player portion here, instead of doing this calculation offset by the camera and then applying velocity to that, we will change that to let me add a to-do here because I'm going to forget since this is going to be next week. Modify velocity based on absolute world position, and then transform to camera position, or I should say screen position. So we'll have to do that for next week, so that the velocity is applied to the position of the ship in world position, and then we have to make sure that that's not going to be a problem for bounding the ship to the screen, so that it doesn't it can't leave the confines of the area of the screen like we had done previously when we were only working in the screen coordinates. Like I said at the beginning of the stream, I'm not going to be streaming again for well, yeah, I'm not going to be able to stream this week on Thursday. Maybe I'll do one on Wednesday. I hate to wait till next Monday because I'm going to forget what I did, and it's a long time between streams. Maybe I'll do Wednesday. If I do Wednesday, it'll be a shorter one, like a real, like a 45-minute to an hour one. But anyway, thanks for those of you who watched. If you have any questions, feel free to ask me live on stream or on Twitter at Claravis. I'm on Nintendo Age. In the Discord pretty often. I will be posting a recording of this to YouTube, so you can check that out also and put comments on there. We're getting close to having completed 50 streams. I was thinking I want to do something kind of cool for that. I don't know, either game related or programming related, but I'm not 100% sure. I also was thinking maybe I could save it till 100, because obviously we're still nowhere near to being finished with the game, and I expect that we'll probably get another 50 streams in before we're even close to being done. But anyway, thanks for watching. Have a great night. Maybe see you Wednesday, maybe Monday. I don't know. We'll see. But I'll post it on Twitter and YouTube. And yeah, thanks for watching. See you next time.